In this final section on speech processing, I'd like to talk about this model for speech processing that we discussed early on in the course. And this model is more of a functional model, and it identifies kind of user features of speech processing, identifying the sound combinations, getting the grammar being used, extracting the meanings of the words, and finding the intended concepts by combining the word meanings appropriately. Now, this is certainly a way of describing speech in terms of user features, but these, what I might call user manual concepts, don't map smoothly into what the brain is actually doing. Phonological type information is certainly being processed in a number of auditory areas, and there are receptive fields that you could regard as having phonological meanings, although partially ambiguous meanings. But what we would call grammatical information is being processed in areas that include those phonological areas, the brain's detecting pauses and variations in stress or sound. But some grammatical type processing could be going on within the indirectly activated populations in the visual areas as well. Word meanings are being processed by indirect activation of visual columns in a range of areas, perhaps up to some very complex areas. For example, a word sound with multiple meanings may need receptive field detections at the groups of objects level to determine the currently intended meaning. Higher-level concept processing may occur in these areas, but these areas also influence grammar and word meaning. So there's lots of information flows between these simple speech processing categories. Or to put it the other way around, one cortical column receptor field may carry recommendation strengths of all four feature types. So the user manual type model gives us a very limited insight into how the brain is actually carrying out the function. The way to understand functions like speech processing is to create descriptions on multiple levels of detail in, for example, the cortex, the basal ganglia, the thalamus, including the thalamic reticular nucleus, and the cerebellum. And with this kind of multi-level descriptions, we can map our experiences of speech into neuron processes.